So for this problem, the same assumptions and knowns are given. So we want to use heat transfer is steady, one directional, and thermal conductivity is constant. Also, heat transfer by radiation is negligible, and conduction is equal to convection. So for this problem, we have a heating element and a glass pane window, and we want to determine the temperature at the front of the heating element. So we're given the outside air, the H thermal conductivity, and we can first say that the total heat transfer is equal to the convection at one side and plus the convection at the other side. Solve for that, plugging in our given equations. We are given Q totals, that's 13,000 watts per meter squared, which is the heating element's heat transfer rate. So then we can solve for T1 and T2, get this equation here. And then we have convection is equal to convection, which is one of our assumptions. So conduction is K times T1 minus T2 over L, and then convection H T2 minus T infinity. Plug in the values that we know. We don't have T2 or T1, then solve for T1 minus T2, get this equation, and then you can use the equation we solved for above, there's two equations, two unknowns, and solve for both. So we want to find T1. T2 is just a value, it's used as an intermediate. So T1 is 14.92 degrees C. So with this problem, Rachel struggled with finding which was T infinity, which was T1 and T2. We corrected this, and it turned out that T2, or T infinity, was equal to 22 degrees C, because that is the initial temperature. And then the final temperature was -5, that's the outside air, so that goes in for T infinity.